Now next we go for the properties of a system. What is property? Any characteristic describing the system. Okay, any parameters which describe our system is called the property. For example, you have mass, volume, temperature, pressure, and density. This is the properties. And we have three types of properties. One is extensive, intensive, and specific property. If we look in terms of intensive properties, the definition is the property which does not depend on the size of the system, whereby the extensive is vice versa of intensive, where the properties of extensive properties depend on the size of the system. And for the specific properties, it's a properties where we have the unit of kilogram at the bottom part of the unit. Okay, so usually the specific properties is being used to change the extensive properties to intensive properties. So these are example of extensive and also the intensive properties. When we divided this tank, initially we have the mass, volume, temperature, pressure, and density divided into two. Then we find out that the mass is also divided into two. Same goes for the volume, but the temperature, pressure, and density remain the same. They remain the same. So these are called as the extensive properties. Change when the size of the system changes. Then this Tp and rho does not change. Then this is called as the intensive properties. Now this is a continuum. The meaning of continuum is when we look into a certain region or certain system, we are going to assume that everything is continuum in terms of the chemical equation. For example, if we have a cup of water, so we assume that in the cup of water, the chemical equation of water is always H2O, no matter where we look at a certain location of the cup. And the second example is the air. We know that the air consists of nitrogen and oxygen. 79% is nitrogen and 21% is oxygen. So if we assume that a certain tank or our system is dealing with air, so we assume that air always contains oxygen and nitrogen. So that is continuum. Next parameter is the density. I have mentioned this density before, and also the specific volume, a very important parameter. But as far as data thermodynamics is concerned, we are looking at the specific volume. It is the most interest parameter that we are having. And we must know that we can get the specific volume in terms of the reciprocal of density. Next parameter is the SG, specific gravity. This is definition of specific gravity. Right? If not mistaken, while I'm in the secondary school, this is also known as the relative density. Okay, relative density. So next one is the specific weight. This is the specific weight, whereby the specific weight is the density multiplied by the gravitational acceleration. Okay, that is the. So you must know all this formula. Okay, the equation. Now we go for the state and equilibrium. State and equilibrium is a state of balance. What type of balance? We have thermal balance, we have mechanical balance, we have phase balance, and we have chemical equilibrium. Everything must be in balance. Okay, equilibrium. When we say thermal equilibrium, the temperature is the same. When we say it's a mechanical equilibrium, okay, we look at in terms of pressure. So we know that pressure is force divided by area. So meaning that the mechanical equilibrium should be equal with the force, whether we are looking in terms of the x-axis or the y-axis. So the pressure or the force must be the same. Okay, for example, if you have pressure, when we say that the pressure inside a vessel or tank as 1 bar, so meaning that that's the only pressure involved in that tank. Now, apart from the outside of the tank, we have the atmospheric pressure, so it should be the same. It does not change with time. Phase equilibrium, we look in terms of the physical appearance of a certain thermodynamic system. When we say it liquid, everything should be in liquid. If it's mixture, it should be a mixture of vapor and also liquid. When we say everything in vapor, so everything is in vapor form. So it must be equilibrium. And also we look in terms of chemical equilibrium that I said just now. We look in terms of the chemical equation. If H2O, H2O, if air, nitrogen plus oxygen, and if we look at R134A, everything should be in terms of R134A. So that is called the equilibrium. So this is an example of state 1 and state 2. When we said this is the state 1 of a certain thermodynamic system, it's always the same properties in terms of mass, time, and volume. Same goes if we have state 2. This is the state, right? Mass 2, temperature difference, volume difference. Because this is a closed system, then we see that the mass does not change for a closed system. And this is we call as the continuum or the thermal equilibrium. We can see that the temperature, right? This is the initial temperature, this is the final temperature before and after. So when we look at the thermal equilibrium, then the temperature should be the same. Alright, so now we go for state postulate. What is state postulate? State postulate is basically the statement said that the state of a simple compressible system is completely specified by two independent intensive properties. Very important parameter, very important statement, whereby we are trying to look at the state of a compressible system. So what is compressible system? Simple compressible system can be defined, or in this our case can be assuming that we have water. Okay, we have R134A, R134A. Then when we set the state, we know that water and R134A could be in several states. It could be liquid, mixture of liquid and vapor, and it could be vapor. Okay, 100% vapor. And it been said that this system, the state of this system, could be completely specified. Okay, if we know two independent and intensive properties. So we know what the meaning of intensive properties. Now we look what is called as the independent properties. So let us look water inside a piston cylinder device or in a container. So this is water. This is our piston cylinder device. Let's say we have 3 states. I'm trying to explain what is the meaning of independent and dependent. Okay, let's say we have water right here. This is the cover of the piston or the piston of the cylinder. Then we have the water inside. This is our boundary. Okay, let's say we have pressure equal to 1 atm, and we know that the boiling point of water at 1 atm is about 100 degrees C. Okay, let's say this is the state whereby this 100 degrees C just reached. Okay, our water just reached 100 degrees C. So meaning that if the water at 1 atmosphere, the boiling temperature is 100 degrees C, then when we look at this temperature and this pressure, we know that everything inside these pistons in the device is in liquid form. Okay, so meaning that for sure we know that this is liquid. And then after that, when we continue to heat this state, what we could have is the mixture. Now the water start to boil. Okay, the water start to boil. So this is liquid. You know that when this happen, the liquid will form as steam, bubble of steam inside. As far as the pressure is concerned, we still have the pressure right here is 1 atm because we allow the piston to move, and the temperature when this happen is equal to the temperature of boiling at 100 degrees C. And if we continue to have the heating process, then we could see that the piston will rise. And let's say this is the state whereby the last drop of water just turned to vapor. Meaning that what we have inside here, everything should be in vapor form. Okay, so this is liquid. This is in terms of mixture. We have liquid plus vapor, and this is vapor. Okay, these three, 1, 2, 3, is called as state. Okay, it's called as state. Right. So let's say this is again pressure equal 1 atm, and the T boil is 100 degrees C. This is unique. This is confirmed from our experience, from our knowledge. This is what we know. The water will start to boil at atmospheric pressure when it reaches 100 degrees C. So we assume this state has just reached 100 degrees C. Still give heating process, and then change phase will happen. More liquid will become steam or becoming vapor in vapor form. Then we still continue the heating process until the last drop of water just turn to vapor. So these are states. Okay, these are states. And if we are given pressure equal to 1 atm and temperature is equal to 100 degrees C, in this case we cannot define the state because we could have three types of states: liquid, mixture of liquid and vapor, and also vapor. So the state could not be defined. So this is called as dependent. Okay, so in this case this pressure and temperature, they are dependent. Okay. Let's say we have another example. We still have the pistons in the device. We have the piston right here. And let's say that the pressure right here is 1 atm. And the temperature is at, let's say it's room temperature, 28 degrees C. Whereas we know that the temperature right here is less than T-boil. Okay, this temperature is less than the T-boil. We know that the T-boil at 1 atm, the T-boil is equal to 100 degrees C. So it's less than the T-boil. So from our knowledge, from our experience, for example, if we open the tap water from our kitchen, there is an atmospheric pressure and the temperature is room temperature. Definitely we will get inside this cylinder is always in liquid form. Okay, it must be liquid, so the phase is liquid, right? So this is called a state. Definitely it will become is in liquid form. And another example, let's say that we have the same thing, pistons in the device. Let's say given the pressure is 1 atm and the temperature is equal to -5 degrees C. Again, the T-boil right here is equal to 100 degrees C, and we know that this temperature is -5, very cold, and this is less than the T-boil. And from our experience, when we put a container initially at room temperature, atmospheric pressure, we put it in the freezer of our refrigerator. Then after sometimes when it reaches -5 degrees C, what we could have right here, everything in solid form. Solid. Okay, solid form. This is called a state. Okay, solid. Definitely it will be solid. So clearly it will be solid. So in these two examples, right? First one, second one. This is what we call as the clearly stated state, which is liquid for this case, and this is for solid in this condition. So right here, what we could conclude that when we can define clearly the state of these two conditions given as far as the pressure and temperature is concerned, so in this case we are looking, or we are getting that the P and T, they are independent. Okay, they are independent. So this is what being said by the state postulate. The state of a simple compressible system is completely specified by two independent intensive properties. So what is intensive? We know that the pressure and temperature, they are intensive. Okay, does not depend on the size. If we change the size of the system, the pressure and temperature will remain the same. But as far as the state is concerned, when the given pressure of 180 atm for water, then we know that the T boil for water is equal to 100 degrees C, and in this case the T is equal to the T boil. Then at this state we cannot simplify or clearly define the state, because it could be liquid when it just reached 100 degrees C. It could be mixture of liquid and vapor, still the same pressure and temperature, and it could be 100% vapor when the last drop of water just turned to vapor. Okay, because this condition, they are the same, right? So they are called, or they've been assumed, they've been subjected, or they are also been treated what is called as the dependent properties. Okay, so they are dependent in this case, whereby the other two state given right here, they are not dependent, because we can clearly specify the state. 180 m 28, 180 m minus 5, in this case liquid, in this case is solid. So this is the use of what we call as the state postulate. Okay.